Hello, this is block 9, assignment number 6, and there are 4 methods that we have learned for solving quadratic formulas. It's solved by factoring, solved by square rooting, solved by completing the square, and solve using the quadratic formula. You have a 4-question homework, and I want to go over how do you know what method is the best. So I always recommend that you try solve by factoring first, if it can factor. If it can factor, you want to make sure that your equation equals 0, that you factor and you set each factor equal to 0. So for example, in this 9x squared minus 4 equals 0, I notice there are 2 terms. One's a positive and one's a negative. And they're both perfect squares. So I can factor this further using difference of squares. So 3x times 3x is 9x squared. And 2 times 2 is 4, with one sign positive and one sign negative. Now that I factored it, I want to set my factors equal to 0. So if I set my factors equal to 0, then let's take a look here. If I set my factors equal to 0, I set my first parentheses equal to 0. I subtract 2 and divide by 3. I get x equals negative 2/3. And if I take my second factor and set it equal to 0, I'd add 2 and divide by 3, so I get x is positive 2/3. So this particular quadratic function has 2 real solutions, 2/3 and negative 2/3. Now square rooting works best when there's an x squared and a c. For example, if you take a look, this is a 3x squared and a negative 12. There's no x term. And the same thing here. This problem has an x minus 4 quantity squared, and notice everything else is just a constant, just a number. So how do I go about doing this? Well, if my goal is to try to solve for x, then what I want to do, I completely forgot the steps right here. I need to make sure that I add those in, right? So the first thing that I want to make sure is that I isolate the x squared. If I were isolating the x squared, what would I have to get rid of first? And what would I have to get rid of second so that I can get the x by itself? So in this particular case, I would have to move that 50 over. And when I move that 50 over, it becomes negative 50. So 2 times the quantity of x minus 4 squared equals negative 50. Now again, I'm trying to get this x minus 4 quantity squared by itself. So now I have to get rid of that 2 that's multiplying by dividing. So I get the quantity of x minus 4 all squared equals negative 25. And now I want to do step 2, which is take the square root of both sides. The square and the square root will undo each other, so I'll be left with x minus 4. And remember, every time you take a square root, you always have to put plus or minus. It'll be plus or minus 5i, because the square root of 25 is 5, and the square root of a negative is imaginary. And the very last step, I'm going to add 4. So my answer is x equals 4 plus or minus 5i. So in this particular example, this quadratic function has 2 imaginary solutions. One that's 4 plus 5i and one that's 4 minus 5i. When is solved by completing the square method best? Completing the square method is best when you have a 1x squared and an even x. So notice that we have a 1x squared, right? And notice we have an even x. So that's when completing the square method is best. So when you have the completing the square method, your goal is to have all of your variables on the left and your constants on the right. So I have to subtract 36. And I'll get negative 36. Then I'm going to take half the middle number, which in this case happens to be negative 12. I'm going to take half the middle number, which is negative 6, and then I'm going to square it, which is 36. This is the number I want to add to both sides. So if I have x squared minus 12x plus 36 equals negative 36 plus 36. So on the left-hand side, I have a perfect square. So I want to write that perfect square as x, because x times x is x squared. I drop the sign in the middle, which is a negative, and I rewrite the 36 as 6, because 6 times 6 is 36. And on the right-hand side, I combine like terms. Negative 36 plus 36 is 0. Then I want to take, on step 4, I want to take the square root of both sides. So the square and square root would undo each other. So I'm left with x minus 6 equals plus or minus 0. And then the very last step I want to do is I want to add 6. And so if I add 6, I get x equals 6 plus or minus 0. Now that could be 6 plus 0, and it could be 6 minus 0. Well, 6 plus 0 is 6, and 6 minus 0 is 6. So notice these two answers are the same. And even though they're the same, you don't necessarily have to write it twice. So since they're the same, you would say it's one real solution. And the very last one is the quadratic formula. And the quadratic formula works all the time. So you want to make sure your equation equals 0. And you want to determine what a, b, and c are. Well, a is a number in front of x squared. B is a number in front of x. And c is a number by itself. And we want to find the discriminant first, because the discriminant is going to give you an idea what kind of answers you're going to get. So b squared minus 4ac. So if I were doing this, this would be 5 squared, which is 25, minus 4 times 3 times negative 1. Negative 4 times 3 is negative 12, and negative 12 times negative 1 is positive 12. So my discriminant is positive 37. And since my discriminant is positive, I'm going to get 2 real solutions, 2 real roots. That's the nature of my root, what type of answers I'm getting. Expect to get 2 real solutions. So the very last step is x equals negative b plus or minus the square root of the discriminant all over 2 times a. So x equals negative 5 plus or minus the square root of 37, because that was b squared minus 4ac, all over 2 times a. A is 3. Now 37 in this particular case cannot break down, so your answer is just x equals negative 5 plus or minus the square root of 37 all over 6. Now what you're going to be doing for your homework is you have 4 problems. They are not in the correct order, so you need to go through them, and based on what we did, determine what method is best. And once you determine what method is best, I need you to solve for x. Have a fantastic day.